You could start recording. Yeah, so I'm going to talk about how we can improve scholarly communication in general using the Open Research Knowledge Graph. So to give an outline, I'll briefly talk about how digitalization is affecting us in the modern times or currently, and what are the problems with the document-centric information flows, and briefly about the Open Research Knowledge Graph, and I will show you features of the Open Research Knowledge Graph, and also how we do data curation within the Open Research Knowledge Graph. So you could see that several years ago, like a couple of decades ago, information flows used to be in mail order catalogs, printed maps, and encyclopedias, and so on. These days, we do not use them. Instead, we have digital alternatives, such as digital maps and a digital encyclopedia, and so on. But when we think of how this information flow is affecting us in everyday life, there are a lot of changes. But if we look into science in general or scholarly communication, about 300 years ago, there were published articles, and it still continued until relatively recently. And only that we have made a published article or the printed article into PDFs, and then we have been becoming better and making better and better PDFs rather than making better information flows. So we focus more on the document and the document-centric flow of information rather than knowledge-centric flow of information. So one could say that science has not completely harvested the full potential of digitalization since around 300 years or so. But also as a consequence of this document-centered information flow, there is this publication flood, which means around more than 2 million papers are published every year, which is by spending around 1.7 trillion US dollars money on research. And this contributes to the problem that researchers, even in a very niche field, lack overview of what's happening. And this document-centered information flow also contributes to loss of knowledge. And if you want to answer a specific question, it is basically like searching for a needle in the haystack, which means it's very, very difficult to find what you're looking for. And other further challenges of the document-centric information flow is that we also have things like a reproducibility crisis, that when some research is done by one group of researchers, it's not reproducible. And there are some fields that are trying to address that more than the other fields. And there's also monopolization of commercial actors, because the commercial actors provide a template or a template for the document and not for the content, because the content is still produced by the scientific community. And there's also deficiency for peer review, because it's very difficult to find peer reviewers for a particular niche subject. And there's also problems of predatory publishing, just to name a few. Can we actually fix all of this? But yeah, you could use digital technologies and then try to search for, I'm just using an example here because I have background in biology, and CRISPR is basically a technology in order to edit genomes. So if I search CRISPR on Google Scholar, so this is one example of a screenshot of the results that I get. Like, it's around close to 1 million results, but it's all documents after documents after document. And if I want to answer a specific question like who applied CRISPRs to a specific group of animals like butterflies, and how to apply this CRISPR technology with minimal costs, or how do these different genome editing techniques compare, I wouldn't have been easily able to find results by just searching through Google Scholar, because I have to go through documents after document, close to 1 million documents, which is, by a human, it is not possible, and it is not even scalable to do that. And hence, it is time to rethink scholarly communication by taking analogies from Oren Harari's quote that the light bulb was not invented by improving the candle, and that is why we should not be improving more and more PDF documents. We should be improving how we can digitalize knowledge and not just documents. So one solution could be with the use of knowledge graphs, because as I already mentioned, the information flow in different areas of ways we communicate or ways we search for products have changed because of knowledge graphs that's widely used in the industry. And why can't we use these for science, or making open science using or leveraging the technology of knowledge graphs? So from papers, you can go into knowledge by using graph technology. So what this basically does is, in a graph technology, you have a subject, predicate, and object, where you have a subject. In this case, it is this article, and it has different elements, which you have, like, Robert Reed is the author of this article, and this article addresses a specific technique, which is genome editing technique in Lepidoptera. Lepidoptera are the group that the butterflies belong to, and it is a sub-problem of genome editing, which has Wikidata entry, and it is implemented by the technology called CRISPR-Cas. And if you want to evaluate it, then you have the experimental data that is linked together. So this would solve a lot of issues where, instead of focusing on the documents, we focus on the knowledge within the articles or within the documents. That would provide us better overview of what we need to search. And that is going to change how we do 21st century science. Hence, the Open Research Knowledge Graph is like a lighthouse in the publication flood. How do we do that? This is by integrating the Open Research Knowledge Graph into an ecosystem of interlinked knowledge graphs and services. So as you could see from this slide, different things like Wikidata, geonames, and internal services like the terminology service from the TIB, and also other elements like Crossref, Altmetric, and DataCite are integrated together in this. So we basically aim to become, or the Open Research Knowledge Graph is integrated well as a good citizen within the ecosystem of interlinked knowledge graphs. So now I'll briefly touch upon the features of the ORKG. As I've already mentioned, we focus mostly on the document-centric information flow, or at least the minimal unit of a productive scientific endeavor is a paper or an article that is published. So in ORKG, we still call them as papers and contributions, where the papers basically describe the scholarly articles, but in a structured and semantic manner. So instead of going into dense text of documents over documents, we try to extract the salient features out of that paper that would be both human actionable and machine actionable. So by doing, or with the assisted graph technology, that is what we do. And while we do that, here you could see that there's a dense text of article about an infectious disease. And from there, there's a semantically structured extraction of what this article uses as approach, and what is the values reported, and what is the hypothesis that is supported. In this case, there's no particular hypothesis because it's just trying to identify a causing agent of a particular disease. And it also provides which kind of samples are used in this, or the materials that are used, and in which location the study was done, and which kind of methods are used, and so on. So you could look into that structured description, or the graphical view behind this structured description is basically that this article has authors and other metadata, and then this article also has this now machine actionable structured features that are extracted from this dense text of articles. So this can make scholarly contributions or any research article both machine actionable and FAIR, which stands for findability, accessibility, interoperability, and reusability. Other feature of ORKG is the comparisons. So comparisons are basically a condensed tabular view of the state of the art for a particular research question. So what you see earlier was, for one paper, we can extract salient features. And in some fields, we can extract these salient features across multiple papers and compare them in order to get a view of what is happening in the field. Because from one research article, there's only one kind of artifact or one kind of knowledge that we get. And if we compare these across different articles, there will be an emergent pattern of either lack of data in certain areas, or lack of analysis in certain areas and so on, and which could be easily compared. And all of these comparisons contains things like contributions, properties, resources, and literals, which are we use semantic terms interoperably, where contributions are basically that these from the articles you extract these mission actionable salient features, and properties are those that can be referred back as resources, and the literals are those values that you extract from these articles. So if you have like a value that is measured, that literal can be represented in the knowledge graph. And here is one such example where you see this is for comparing different studies across the things that are done in different study areas during COVID-19 pandemic. So as you could see, these different columns represent different articles, and the column in the gray is basically the properties of that are compared across these different articles. So you have like location, time period, when it has begun and when it has ended. And in this case, it is basic reproduction number or R0 number, R0 estimates of COVID-19 COVID-19 virus. And there's also upper limits and lower limits of this value, and it has a method, and it's compared across different studies that are done in locations like Italy, Iran, and Singapore. And one could extend this. It's actually a very large comparison of more than 30 or so studies. But in this particular screenshot, you just, to illustrate that, I'm just showing 4 such examples. So with this being one of the powerful ways to compare across different studies, as I was already mentioning, you could see what are the data patterns that are emerging, or if there are data gaps and so on. You could also visualize using the ORKG for these comparisons, which are normally not present in one article, but then you collect multiple articles and try to visualize what is emerging out of all these comparisons. So this is one such example where, again, of the example of COVID-19, where you have a number of cases that are in blue and a number of deaths that are in red across different studies from this particular comparison. So this would not be possible just by looking into documents after documents, but with the Open Research Knowledge Graph, one could clearly see this. And in the this was not exactly done at the early stages of the pandemic because the articles were still coming on and there were a lot of confusions around that area. But this could be used for future monitoring of any emergent outbreaks and so on. Another feature of the ORKG is that you could, once you make these comparisons across different articles, you as a researcher can also be acknowledged for making this comparison, which means you can have a citable permanent identifications, permanent identifiers such as DOI, which means this record would be available in the internet, which can be later cited. And you can also visualize the created visualizations, and there's also interactive filtering for what kind of properties you need to compare across these comparisons. For example, if one has extracted a lot of features about, again, I use the COVID-19 example, and then these are virologists who are trying to analyze something. But if an economist comes and says that I want to also look into the economic aspect of that, and then if that data is already extracted, then they could also compare that by filtering just the economic data and leaving out the rest of the things that would be more meaningful for virologists than economists. So this is also one way of expressing knowledge generation and trying to get or trying to be credited for that using a citable DOI. And that brings me to the workflow that we currently have. We also have other elements or other features such as templates, which are basically like an input form for a particular or particular field, which are developed together with experts in the field. So that way you don't have to think about semantically modeling or structuring the data. All a domain expert has to do is just to input these fields, and then that would be transferred to the knowledge graph. And we also have lists because while we do research, we always try to collect research articles as lists or collections. And that list can then be organized into topics, and from those lists, you can input them into the ORKG papers and contribution, which semantically extracts the salient features. And that can then be compared across multiple articles, which can lead to a visualization. And together, these visualizations and the emerging trend, you can write a systematic review or a review on that, which we call it as dynamic ORKG reviews. And then this can be looped in as and when new articles are added. So that is the current workflow of how we enter data into the ORKG, which is most often a human endeavor, or there's always domain experts at the end who are trying to curate this list of articles and then trying to enter the information into the Open Research Knowledge Graph. And with that, we have the current system that we have is describing not all the more than 2.5 million papers that are published, but because it's a human endeavor, we only have more than 28,000 well-described papers that are in the ORKG, which actually covers a large variety of problems, around 6,000 research problems. And that is compiled into more than 1,000 or close to 1,500 comparisons. And they all have a different number of visualizations for each of these comparisons, which are created by around more than 1,500 users that are using the system. And ORKG by definition is radically open, so it is open for anyone to join and contribute. So it is also a domain agnostic knowledge graph, which means that it is not just focusing on one particular domain. So we could try to find, or the goal is that we want to have every scholarly knowledge that is published, or everything that is in the published literature, we want them to be represented in the Open Research Knowledge Graph. And for the curation of the Open Research Knowledge Graph, we use a crowd-based approach because we have, as I mentioned, most of it is a human endeavor. And also, everyone is welcome to create, edit, or add and complement and reuse existing comparisons or existing salient features that are extracted out of an article. So we have, as I mentioned, more than 1,500 active users who are also domain experts, and we sometimes consult domain experts in order to get the right modeling of certain fields and certain articles within the field. And we also have librarians or the subject librarians and information scientists who work together in order to curate the Open Research Knowledge Graph. On top of it, we also have our advisory board and user board, which are recent additions, who try and steer us in the directions that we need to really take into account of which topics are very essential for us to have those representations within the Open Research Knowledge Graph. So one thing that I already mentioned is that we have a lot of human in the loop, or we have a lot of manual data entry where a human has to add a paper manually. And as you could see in this figure, the better scalability increases with full automation, which is like currently we have something where a human user or a domain expert enters a paper manually within the system. And then there's also gradations between having fully automated system versus human adding that or manual contributing system, where we have machine in the loop, where machine provides assistance and the human leads, and human in the loop where a human or a domain expert or a human curator looks into the actions taken by machine assistants or the produce knowledge from the machine assistants in order to curate knowledge for better. So we basically focus on the machine in the loop and human in the loop model, which are currently being tested within the ORKG, so if you go into the ORKG system, and as I mentioned, the basic unit of publishable science is basically a paper or an article. So that is what we have here. We have something called as add paper wizard, which when you import the article, most of the metadata is already extracted from that if it is in the right format. And then there are also description of the contribution data, such as the salient features are extracted. So for that, we use some machine assistance. So there is some kind of smart suggestions where in this case, you could see that the highlighted fields such as research problems, solutions, and methods are extracted from this article that has been provided as an input. And then a human user can actually decide whether these are the right ones that the machine assistants are provided, and that can be added or edited according to the human user or the domain expert, however they wish that needs to be represented as close towards the truth. And in the human in the loop model, what we have is that when we have machine-generated knowledge, then also for the human-generated representations, another human curator or a domain expert could go and say that these representations of this particular article are correct and accurate, and then they could give or each user could have different types of oaths, and then they could also indicate that this one needs to be changed or this one needs to have a better description, and if there are two terms that are similar, then what they mean by that, and so on. And that is also possible. And we are using such systems within the Open Research Knowledge Graph in order for the humans to make decisions on what kind of representation is the best, which has been either generated partially by machines and curated by humans already. And also this helps that if you as an author of an article see that your article is represented in the ORKG by another author because they tried to do a larger analysis of the fields comparing different articles, and then you find that maybe there's some mistake in one of the representations, then you could actually go and say that this representation is wrong and this is how this should be done. And then you could add that addition as a separate comparison and publish that crediting yourself. And we also have something called as the Open Research Knowledge Graph curation grants, so which should be open soon. In the call would be open sometime soon in spring, and this is a program where we work closely with the domain experts in order to curate research or articles from their field across the ORKG. So this is a grant program where the researchers are closely involved in also providing suggestions on improving features for the ORKG, where their domain can benefit from. So if you are interested in trying out the Open Research Knowledge Graph, please do look out for the call that would be announced sometime in spring soon. And one other idea is that we also wanted to use these ORKG comparisons to support peer review. So we have collaborations with some conferences where the authors submitting manuscripts to those conferences can also add a comparison in the Open Research Knowledge Graph in order to provide what is new in their contribution or in their article, and then try to provide a state-of-the-art comparison across what has been done in the field. And this also helps the peer reviewer to see the merits of the work that has been done, and hence this would help in improving the quality of research and the quality of peer review itself. And if you want to have a subject-specific knowledge graph, then we call them as observatories. So we operate a lot of observatories in collaboration with disciplinary experts and domain experts, where the domain experts come together and try to define the research problems or the data gaps that they have, and they try to represent those in the ORKG. And in addition, they also provide feedback on what in particular we can provide for their domain so that their knowledge is represented in a way that can be more machine actionable, and it's also compliant with findable, accessible, interoperable, and reusable principles. So that brings me to summarizing this talk that we need to rethink scholarly communication, where scholarly work can also be realized as expressions other than articles, such as the emerging patterns that come from comparing across multiple articles. And also, we need to make knowledge both human and machine actionable. In this particular case, we use a crowd-based approach, combining domain experts and data curators, but we also have a lot of machine assistance where the human leads and the machine provides assistance in generating the knowledge, which can be then curated. So with that, I would end my talk, and thank you for your attention. And then I would be happy to answer questions that you have.